Okay, on to numbers 6 through 10. So we want to look at number 6 here. On what interval is the graph of 3x squared divided by e to the x concave down? So I know concavity, it deals with the second derivative. Quick pointer, if you see decimals such as these in the answers, 3.41, 0.58, you can, it's probably going to be a on the calculator allowed section because you're not going to be calculating those kind of decimals in your head. So really, we could just look at this graph and sort of estimate where it's concave down. It shouldn't be that bad. I haven't looked at it yet. But we definitely could go to the second derivative and find out when f double prime of x is negative. So when f double prime is less than 0, the graph is going to be concave down. So let's graph it real quick. 3x squared divided by e to the x. So we've got 3x squared divided by e to the x. All right, so it looks like this graph changes concavity somewhere around here, and somewhere around here. And that might be around 0.58, and that might be around 3.41, but we can verify using the second derivative. So let's do the second derivative. It's not hard with the Inspire, so we just bring back up our function editor. F2, we go to our template button, and we bring up the second derivative here. The second derivative with respect to x of f1 of x. We enter, and we want to find out where this graph crosses the x-axis. So bring these over, and let's do this. So I'm going to go ahead and use the menu, analyze graph, 0. It's asking me what graph I want to do. I want to do my second graph, graph 2. And I want this, so I'm going to go to the left of the 0 somewhere. And I click once, and then I spread it to the right, and I find 1, 0. It's at 0.58 approximately. And then I can do the same thing for the next 0. I can do menu 6, 0. This graph here and here, and I find it's at 3.41. So it's concave down. It's negative between 0.58 and 3.41. So we go back to our question. It's negative, concave down, between 0.58 and 3.41. All right. So not too bad. Calculator helps out a lot. Let's clear our annotations and move on. Line tangent to the graph of that at 2, 1. Calculator allowed. All right. Well, we can do this without a calculator, I think. So we're going to take the first derivative on the slope of the tangent line, and then we're going to put it in and use our point that we were given. So we've got 3x squared plus, we got product rule here, so we're going to leave the first piece alone, take the derivative of the second piece. So that's 1 dy dx, I'm not going to write the 1, plus, so this is I guess in brackets, plus the second piece times the derivative of the first, which is 1, so I'm just going to leave it like that, plus 3 y squared dy dx equals 0. All right, so I'm going to combine a couple things here. I'm going to leave the 3y squared dy dx all the way at the end, plus x dy dx on this side, because I want them to stay positive. And then I'm going to subtract 3x squared and y to the other side, so that I end up with this. So I basically I took these pieces and moved them to the other side here. And there. So now I can divide, or what I can do is factor out 3y squared and x, and I'll be left with a single dy dx, and I'll divide the 3y squared plus x. So that's going to look like this, and I'm just shortening a little bit because I'm running out of time and space. I don't want to make these too long. So negative 3x squared minus y. And what I'm going to do essentially is, I know that I have a dy dx in common here. So this is what's going to be left inside the parentheses once I factor out dy dx. So it'll be left isolated, and I'll have the quantity 3y squared plus x. So now that's dy dx, and I want to find the slope of that. I want to find the slope of that line. So I'm going to plug in 2 and 1. Remember, 2 is my x, and 1 is my y. So when I do that, I get negative 3, and my 2 squared minus 1, and that's substituted there. 3, 1 squared plus 2. So 2 squared is 4, times negative 3 is negative 12, minus 1 is negative 13. And the denominator will be 5. So our slope is negative 13/5, and the only one that even remotely resembles that is a. So since a is the only one that has that slope, that's got to be the one. And we double check. There's our y value right here, and here's our x value. Remember, point slope form, the slope. Okay, so it all checks out. So let's move on, and let's clear the annotations. Okay, function is given. What is the x-coordinate of the inflection point of the graph? So, inflection point, inflection point, that tells us automatically that we know this. Oh, come on. All right, so, and again, so the decimals. I think this is going to be a calculator aloud question because our decimals are like this. So, and I don't think we're going to be able to solve that for 0 very easily. So, back to the calculator. I'm just going to make a new page. All right, so F3, 2x to the 2/3. 2x to the 2/3. Minus 1/5 x to the 5/3 minus 1/5 x to the 5/3. Okay, a lot. Crazy graph. All right, so now I want the second derivative. I'll bring that back up. Okay, so I'm going to go here, my second derivative there with respect to x, and I know my first function here is f3 now, so I'm going to just type in where I put that function. And, okay, so what do I want here? I want the x-coordinate of the inflection point. All right, so we look back at our document here, and okay, so if we look at the graph, and we got the second derivative, we're not finding from the second derivative anything useful. It's all negative, and we notice it's not differentiable at 0, but that looks to be where the concavity would change. So let's do this. Yeah, because it keeps saying concave down for that. And right, so go back to the question. It looks to be 0. So let's see here. Alright, so I'm thinking this is either 0 or negative 1.58, because if you look at this graph, it kind of looks like it does one of these things, which would change concavity right about at that point. So it kind of looks to me as if it does that here, but I'm not sure because the second derivative doesn't tell us that it does. So I am going to be bold enough to say that I'm not sure, but I think it's either C or D. So one of the two, and I'll double check that and tell in class what I found. So we got to move on so we can finish this before the 15 minutes are up. The graph of that is concave down, so concave down, second derivative. So we go first derivative, 4x third plus 24x squared minus, 144x. Second derivative is 12x squared plus 48x minus 144. Factor of 12. And will that factor? Possibly. All right, so I know concave down. I'm going to find the inflection points first. So when this is 0, so that I can find where it changes concavity, and then I'm going to try values that are in between those and on the outsides just to test the concavity. All right, so this does factor plus 6 minus 2. So x is negative 6 and 2. So it's going to be either A, B, or C. So what I'm going to do is I'm going to test negative 7 and see what my answer is. So if I plug in negative 7, I get 49, or 12, and then 49 minus 28 minus 12. All right, so 49 minus 28 is 21 minus 12 is a positive number, whatever it is, times 12. So positive means that it is concave up. So I know that if negative 6 is a point of inflection, and outside of, to the left of negative 6, is concave up, then it changes concavity to go to concave down between negative 6 and 2. And 0 is an easy number to try between there. So if we do 0 squared plus 4 times 0 minus 12, we do find that it is 12 times negative 12, which is negative 144. So between negative 6 and 2, it's negative. The graph is going to be negative, so that is going to be concave down. And 2 is an inflection point. So if it's concave down between those two values, after 2, it's going to go back to concave up. So I know that my answer is A. And I'm not going to get to the last one. I'll put that on a separate video because I'm running out of time. So there we have numbers 6 through 9.